In September 2021, Tradelossa was assigned to the transportation of a WMR compressor suction KO drum, alongside other multiple heavy haul components, from the port of Ensenada to the storage area of the LNG plant Energía Costa Azul, ECA, located at El Sausal, Baja California. Project ECA became a milestone for Tradelossa, surpassing the limits of what a traditional hauling project can be and bringing all kinds of customized services and civil works to our clients. Shipment routing, sector, oil and gas industry, cargo, WMR compressor suction KO drum. Dimensions: 117.126 feet in length by 24.048 feet in width and 26.541 feet in height. Weight: 765,004 pounds. The route followed a 22.36-mile journey within the state of Baja California. Physical elements: Energía Costa Azul is a storage and LNG terminal committed to the social, environmental, and economic development of Ensenada, contributing to the energy security by supplying natural gas to electric power plants and other industries located within the state. The project site is located at El Sausal, a small town between the city of Ensenada and the border city of Tijuana, one of Mexico's most circulated areas within the northwestern region shared with the USA. The cargo had to overcome many obstacles along the journey, such as traffic jams, bridges, power lines, roadblocks, toll booths, traffic lights, and road sections under repair. Tradelossa's team was able to overcome these complex outcomes by choosing the right equipment and preparing a year prior for the execution of this project, and by taking charge over the necessary civil works along the route, acting as leaders, setting a contingency plan for each one of the components, and relying on a skillful crew full of professionals. Planning the job. Man-hours: 1,440. From September 2021 to May of 2022, Tradelossa was dedicated to provide a plan that would meet the client's standards. Starting with the analysis of the route, our team visited the site and its key points and challenges along the route. Once all information was gathered, such as port specifications, toll booths, populated areas, road sections, bridges, power lines, traffic lights, and civil works, our engineering and operational team worked to define the best course of action and the most suitable configuration for the compressor. By gathering all data from the route and the cargo, our team considered two main configurations as options. The first one was a parallel combination of 6 axles plus low deck and 6 axles hydraulic configuration. The second option was a parallel combination of 8 axles plus low deck and 8 axles hydraulic vehicular configuration, with each axle having 8 tire lines designed to hold and redistribute the cargo's weight. Choosing the first option as configuration for the compressor would have failed to provide a stable center of gravity because the transport was lacking enough width to act as a proper base and would force the equipment to hold more weight per tire, putting the piece under an unnecessary risk. To solve this, our engineers created the second option, providing 2 more axles and a parallel configuration. This gave the cargo a wider, longer, and more stable configuration to maintain the balance of the cargo's gravitational center. Also, offering a total of 16 axles with a low deck to redistribute the compressor's weight, assuring its safety during the venture. Permits. Several permits had to be issued, such as civil work permits, clearance and utility permits, transportation permits, and coordination with port, local authorities, private and police escorts. Safety considerations. Personnel with proven capabilities and certified for truck operation, field supervision, general support, and civil work engineers. The use of a front saddle, 2 middle saddles, and 1 back saddle as specialized support. The equipment used was a wide hydraulic vehicle configuration, a parallel combination of 8 axles plus low deck and 8 axles, with 5 prime movers, 3 at the front and 2 at the rear, which gave us outstanding capabilities to execute road transportation with high standards and quality service. 78 sets of specialized chain equipment for lashing. A total of 56 chains for longitudinal forces and 22 chains for lateral forces were required to secure the cargo to the trailer and keep it in place, avoiding rough moves while on the road. The cargo was also secured with insulated material to prevent any electric arc and escorted by staff dedicated to provide support on clearances and obstacle removal along the route. Permitting, luminaire equipment, and use of adequate safety equipment. Use of escort cars to assist the trailer and local police escorts to prevent traffic incidents, along with constant coordination with all Tradelossa's team involved in the project. Execution. Man-hours 1,120. After almost 9 months of negotiations, reviews, planning, permitting process, testing, and in-house preparations, in May of 2022, Tradelossa's team put all plans in motion, starting first with the execution of the multiple civil works required on multiple points along the route, followed by the transportation of the components from October to December of 2022. All civil works for the project were completed in a 4-month period. During this course, many components arrived at port, and Tradelossa took on the task of receiving every new component and loading the cargo directly from the vessel to a shorter configuration where it was stored at port until departure. Leaving the port of Ensenada wasn't going to be easy. Our team realized that the compressor width exceeded the port's original threshold measurements, so Tradelossa had to negotiate with federal authorities and propose an extension for the gateway. All these efforts led to an agreement, and the federal authorities green-lighted the modifications at the port. The government of Ensenada requested that all hauling operations for the compressor and other oversized items had to be executed after midnight as a safety measure for Ensenada's population. On December 20th, 2022, Tradelossa started the rigging and hauling operations for the compressor, loading the piece with the use of an 800-ton hydraulic gantry to the main transport configuration and departed at midnight. The city of Ensenada. Once the cargo departed from port, the only road leading out required our team to move against the flow of traffic, so we sent out pilot units in advance to hold back the traffic. We also had to implement clearance services in advance for power lines, signs, and traffic lights for almost 8 miles. However, because this highway is the main access to the city of Ensenada, it was very important to execute all operations on schedule and following the highest quality and safety standards. After passing this part of the journey, our team and the compressor were about to encounter the next choke points within the route. 2 15-foot-tall bridges unable to be lifted and blocking the cargo's passage. The first bridge was situated at an intersection leading to the University of Baja California, UABC, and was used for vehicular access. The second bridge, located 1.24 miles ahead at the Center for Technological Studies of the Sea, CETMAR, served as a pedestrian bridge for their students. Tradelossa foresaw these challenges and sat down with the local authorities in the winter of 2021 to review possible solutions. During the following months, our engineers presented a plan that would let the compressor and the other components bypass both of these bridges. For the UABC, the solution was to access the campus through one of their intersections with the crossing highway. Our team proposed several civil works like the widening of the highway off-ramp to the school, reducing the road superelevation, and the removal of long sections of concrete curbs within the campus that kept the roads divided. It also required clearances for power and communication lines inside and outside the UABC. For CETMAR, the plan was to build an entirely new ramp access for the school with enough width clearance to fulfill a safe passage for the 765,000-pound compressor. The proposal also included the removal of an arch structure located at the school's parking lot exit. Both UABC and CETMAR were unsure of the outcome, but thanks to the efforts of our engineers and operation team, both institutions believed in the project and realized that these civil works would not only assure the safety of all parties, but would also contribute to their own projects of modernization. In one night, Tradelossa's team had moved the compressor from the port through the city of Ensenada and bypassed the bridges at UABC and CETMAR just as planned. This brought us to the midway point of our journey, the municipality of El Sosal. During this part of the route, more civil works had to be performed. This included the lifting of a pedestrian bridge at the city limits of Ensenada, an operation that demanded great coordination from Tradelossa's team because it meant that while the compressor was moving, a separate team was preparing the lifting of an entire bridge section, providing enough height for the cargo to safely pass through. Waiting ahead for us was the toll booth, San Miguel de Allende. Our team planned a detour to continue along the main route, due to a continuous span girder bridge between the toll booth and the federal highway, since the compressor's weight was too much for this bridge. This strategy permitted the cargo to not only bypass the bridge, but also access the toll booth through their yard area, giving our team and cargo the perfect space to rest and resume the journey during the next night. The Great Bridge of Manantiales. The next step along the route would become the major and most demanding civil work for the project, the bridge strengthening of Manantiales, a segmental bridge conformed with 3 spans. Each of the 3 spans of the Manantiales Bridge has a length of approximately 118 feet and is located up to 82 feet above the terrain. The 29-foot roadway itself is supported by 4 girders. To ensure that the compressor could cross, the bridge had to be structurally reinforced, as it was not designed for such weight. In addition, a special project requirement was that the road could not be closed at any time during the refurbishment work, since it is the main connection access between Tijuana and Ensenada. Our unique solution was the installation of a specialized support system for the bridge's static reinforcement by using a shear carbon fiber and external pre-stressing system based on post-tension carbon fiber. Each girder was equipped with 4 systems and reinforced with a total tension force of 880 kN, increasing the capacity of the bridge by 25%. In order to not damage the existing and intact pre-stressing cables inside the girders, a project-specific anchorage was also designed, allowing all 4 systems to be anchored to it at once, helping to minimize the preparation work, which would have had to be performed at a great height. These were the first anchorage operations of their kind within the entire Latin America region. Preparations were carried out months in advance, and all operations were undertaken with world-class safety and quality standards in coordination with Tradelossa's reliable partners. Completing the job and access to site. Tradelossa's team was nearing its destination, but there were some final obstacles. Our team was confronted with one last vehicular bridge blocking the way. We had to take one last detour, bypassing the bridge by using a very narrow off-ramp on the other side of the road. But the transport also had to cross a section of the highway full of sharp turns, demanding the team to maneuver through each turn with outstanding precision due to the narrow limits of the road. To ensure the cargo, crew, and highway users' safety, there was a coordinated effort with local authorities to hold all traffic on both sides of the highway for 5 hours from San Miguel before finally arriving at the ECA site. To gain access to the project site, the cargo had to descend a 9% slope of 1.24 miles. Tradelossa's engineering and operational team had anticipated this event by implementing the use of a truck configuration specifically designed for this obstacle, consisting of 3 prime movers at the front to lead and 2 trucks at the back to resist the slope, capable of hauling up to 700 tons as the compressor was carried safely down the slope. Conclusions. With a total of 2,560 man-hours, 1,440 hours for planning, and 1,120 hours for execution and delivering, Tradelossa successfully completed the transportation of the WMR compressor. To this date, the project for Energía Costa Azul has completed over 180 additional freight trips with several similar oversized components, some larger and wider than the compressor, with impeccable coordination and safety, covering more than 7,000 miles traveled. The key factor that allowed us to overcome this complex challenge was our team's broad experience and dedication, as well as the coordinated planning with creativity and determination to accomplish the goals set by our customer, delivering a top-quality performance. But more importantly, the completion of these civil works required for this project will also benefit public and private sectors within the state of Baja California. World-class customer, World-class safety and service standards. World-class team. Tradelossa. 50 years moving the industry.